All right, eighth grade. Today we are starting topic 12, where we are going to be looking at the Pythagorean theorem and getting used to mathematical reasoning and using proofs. So our learning goal is to explore the basic principles of a mathematical proof. You'll see a lot of these in geometry, and you'll see some in algebra as well. So when we talk about a proof, we are proving that some mathematical concept is true. So it's a logical, deductive argument in which every statement of fact is supported by a reason. So we will always have um, statements listed, and each of those statements will be supported by a reason that proves it's true. So the reasons that we list over here could be a property, like the distributive property. It could be a definition, like the definition of a right angle. It could be an assumption, or sometimes it will be given facts, a fact that is given to you or presented. So when we talk about a proof, that's different than a theorem, in the sense that a theorem is a conjecture that is proven. So theorems can have a list of statements supported by reasons to back them up. So let's take a look. Given that 3 times the quantity x plus 5 equals 45, prove that x equals 10. So we're going to complete by writing in the correct reason that justifies each statement. So this is a great example of what a proof looks like. You can see our statements on the left and our reasons on the right. So I need to start with statement 1. This is the problem that is given to me. This is presented to me, it's given, and it's stated that this is given to me. So my reason for being able to make this statement is that it's given. We are going to accept it because it is given to us. Statement 2. Now we are saying that 3x plus 15 equals 45. Well, we need to think about logically, mathematically, how can we prove that? What do we know that proves that I can move from this first step down to this step? So I'm sure you are recognizing that what we have done is removed the parentheses to get to the second step, and we've done that by distributing here. We've multiplied the 3 across this expression to get 3x plus 15. So our reason to justify that statement is the distributive property. That tells me why that's true. In our third statement, now we're saying that 3x equals 30. So we need to think, how did I get from step 2 to step 3? I still have a 3x over here, but now I've got a 30 instead of a 45, and I don't have this 15. So what we did was we subtracted 15 from both sides. So because we subtracted 15 from both sides, we can use the subtraction property of equality, which says that if I subtract the same number from both sides, that my equation remains equal. And finally, our last statement is that x equals 10. Well, how did I get from 3x equals 30 to x equals 10? That would be through division. So I have divided both sides of the equation by 3. And that got me from 3x equals 30 to x equals 10. So I justify that with the division property of equality. When I divide both sides by the same number, my equation continues to remain balanced or show equality. So this would be my proof. Let's look at another example. Given x divided by 2 minus 12 equals 37, prove that x equals 98. So we're going to complete this proof by giving the reason that justifies that second statement. So our first statement is given to us. So that is my reason. This is given to me. So that's why I can make this statement. So now I need to consider, how do I get from this equation to this equation? What has changed? And if we look closely, we see that the x divided by 2 remains, but this minus 12 is gone. And this 37 has changed to a 49. So because we are so savvy mathematically, we know that we have added 12 to both sides, right? So we would call that the addition property of equality. That is my reason that I can make this statement, that x over 2 equals 49, because I know that this addition property of equality tells me I can add the same number to both sides of the equation without changing its value. So next, to get from the second statement to the third, I've gotten rid of this divided by 2, and my 49 became a 98. To do that, we multiplied both sides by 2. So the reason I can say this is because the multiplication property of equality tells me that I can do this. So now in those 3 steps, I have justified that x divided by 2 minus 12 equals 37 as the solution of x equals 98, and I've given my 3 reasons. This also works in geometry, and you will see proofs in geometry a lot. So let's take a look at one that revisits some of the angle relationships we just studied a few topics ago. It is given that A intersects B. So I can see line A, and it intersects or crosses line B. Write the missing statements and reasons in this proof that the measure of angle 2 equals the measure of angle 3. So that's what we're trying to prove down at the bottom. We're trying to prove that the measure of angle 2 equals the measure of angle 3. And I'm starting with the given fact that A intersects B. So that is my first reason to support my statement. A intersects B. My second statement says that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And I know this because angle 1 and angle 2 are adjacent angles, meaning they're right next to each other, right? They share this side, they share this vertex, they're adjacent, and they form a straight angle. So a straight angle is 180 degrees. So if these are adjacent and form a straight angle, then when I add them together, they have to equal 180. My third statement, the measure of angle 1 plus the measure of angle 3 equals 180 because angle 1 and angle 3 are adjacent. These are also next to each other. They share this vertex, they share this side, and they form a straight angle. So when I add them together, these also have to equal 180. So now I need to fill in my missing statement. So this time, by substitution, I can prove that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 3, because each of these equal the same thing. So I have replaced 180 with the measure of angle 1 plus 3. And now, if I need to prove that the measure of angle 2 equals the measure of angle 3, then I need to get rid of the measure of angle 1. So if I want to get rid of something that shows up on both sides of the equation, I can subtract it out. So by the subtraction property of equality, if I subtract the measure of angle 1 from both sides, then what I'm left with is that the measure of angle 2 equals the measure of angle 3. All right, one more. It is given that angle A and angle B are right angles. Write the missing statements and reasons in this proof that angle A is congruent to angle B. So let's start with our statement. It is given that angle A and angle B are right angles. Second statement, the measure of angle A equals 90 degrees and the measure of angle B equals 90 degrees. And I know this by the definition of right angles. I know that that's what it means to be a right angle, is to have a measure of 90 degrees. By substitution, I can determine that the measure of angle A equals the measure of angle B. If I substitute the measure of angle B in here for 90, then what I'm left with is that the measure of angle A equals the measure of angle B. And then I can conclude that angle A is congruent to angle B because angle measures, or angles with equal measures, are congruent. You are now ready for your 12.1 digits homework. You will do great.